use on the Balloon project, and also demonstration setup of the transmitter and using SDR. So with balloon flights, there's this website UK has, which is extremely useful. It basically tells you everything you need to know for both the hardware, software, and the regulatory aspect. They give you loads of software for Arduino to try things out, and that's the basis of the demo I've used. So what I'm going to do is look at the components and the work in the worksheet. So one of the principal components is the GPS receiver, and this is the U-blocks that Richard referred to. This is the second kit. So that's the U-blocks chip, and then this is a breakout you can get with, in this case, the Sarantell antenna, which is disconnect. Okay, so that's the breakout. Right. So it's quite a small LCC package. It's got UART and DDC for setting up parameters. It can support up to 50 channels. It can go up to 50 kilometers and handle temperatures down to -40. So it's suited to the kind of application that we're working with. It's relatively low cost. It's £20. That is £20. Which is useful because I've blown. Yeah, and it's a 3-volt device, right? Not a 5-volt device. So when you connect these to your Arduino, make sure you connect it via the 3-volt free port. If it's a Uno or you're using something like ProNet, which is a 3-volt Arduino. Okay. In fact, this is true of most devices nowadays. Is that they're 3-volt, whether they're sensors, transmitters, or GPS. So you're better off using something like a ProNet than you are using a Uno or a Lino or anything like that.
So is it pure GPS or Glasnost?
Okay, this one does Glasnost as well. Glasnost is the Russian flavour of GPS.
But you're in one mode or the other. I think you can set it up into the Glasnost, but it can't do them simultaneously. I think is the way I read the data sheet.
I don't think you're going to have perception.
Well, you get more accurate fixes if you combine the two as well.
You get more satellites. See. Okay, so I haven't played with GPS, so I thought I'd understand in case others have. What this will do is if you just connect the transmit pin up to the receiving pin on an Arduino and power it up, you'll start seeing GPS messages coming out. Yeah, so this is the GGA. And this gives you most of the data you need, like latitude, longitude, which direction. It doesn't give you amplitude though, it will give you a time fix. No, it does give you amplitude. So that number there, 9.0, is the height in meters. But there are a couple of other messages to look out for. So when you're going to be decoding messages to extract data, like altitude, velocity, whatever, and it's a fairly simple string setup, and it will carry CRC error check.
You can turn the different messages on and off, and there's more messages you can turn on, or if you don't want to know, like the satellites, the GS satellites in view, for instance, you can turn that message off. So yeah, or just ignore it. There is a package that comes with it.
This was £20 for if you go onto the UK Has site. There's then a link off to this guy who specialises in the ballooning side of thing. And that's where I got. You can get it with an SMA adapter rather than a Sarantell helical. There are other antenna options. It's very easy to set up. Very prompt as well, quite quick. Right. The other major component is the NTX transistor that Mike referred to earlier. So it's a silver box where we've got 7 connections. It's the maximum power we're permitting on a transmitter is 10 milliwatts. So that's the maximum power this allows. You have a ground range of about 500 meters. Okay, so it's a 434 megahertz transmitter. This one is fixed frequency. So this is a 434.075. 0.075 megahertz transmitter. But one that we're looking at in the context of the project is a frequency agile one that you can interact through the SPI port. UART.
It's just a UART. There's a transmit enable pin, but if you actually send serial data down, you can change the frequency and trim also the frequency as well, and save that to memory.
Right. So that's a mod done by the Balloon system supplier. The transmitters you get from Radiometrics direct are either the 075 or the 650 variants, and this is the one that is recommended off the UK NASA.
Is that because that's what the networking ground stations are already listening?
Yes.
Are they on
Yeah,
the
they'll be
Telesat
listening
side?
on that frequency.
I mean, if you look at their mailing list, they got quite a range.
Well, they do have range, but then if you look at the ones they recommend, it's relatively low power, 20 milliamps. So in fact, you could drive this and the GPS off of a Pro Mini. So a Pro Mini is around about 100 milliamp maximum power it can put out 3 volt pin. A Uno can do something like 800 milliamps as well. That transmitter is about 20 odd amps, and that's for the frequency agile as well as this fixed frequency unit. So the way it works is frequency shift key. Basically from 0 to 3 volts on the transmit pin. So you get a 6 kilohertz range either side of the baseline frequency. The UK has a lot of code on there for experimenting with Arduino and
And it's simply a modulator. It takes an audio input predominantly and just translates it up to 400 megahertz and dumps the same audio out.
Well, so you're doing frequency shift keying of the carrier.
But you're doing that in the inputs.
You're doing it. Yeah.
It's not doing an FM modulation inside.
Well, actually, what you feed it is they do
I think it was a
PWM. So you waggle the transmit in the PWM, and they translate that into Gaussian scan.
But basically, within the band, whatever voltage you put on the transmit pin will determine the frequency that comes out of it.
okay.
So it is.
So it's single tone at a time, logical.
Yeah.
Right, so what do you send out? So what you transmit is RTTY, radio teletype. So this has a very long and distinguished career. It should be used in shortwave communications. It's still used, weather, military, diplomatic, usually ciphered. They're used quite a lot by amateurs. You represent 0 and 1 digital states with audio tones. And use that to modulate their single sideband transmitter. The coding follows the standard as the ITA2 symbol set, which uses 5 bits, which you can shift, and that allows you to cover the 32-bit character range. This is Bodot. But then, well, Bodot was the original code set, but then it's been standardised with some variations to ITA2. You can also have 7-bit symbols. This tends to be what gets used for the balloon telemetry. You have 1 star and 1.5 or 2 stop. Never understood what 1.5. And then when you're talking about baud rate in radio and RTTY, it means symbols per second. Unlike with modems, where the manufacturers use baud rate to talk about bits per second, so not the same at all.
Well,
And then, so if you're then looking at real baud rate, which is symbols per second, then there are a couple of standard baud rates. The one that seems to be used mostly for the balloons is 54. although there's some experimenting at 300 baud, and this is where they're doing image transfer. And also people are looking at using 600 baud for slow scan TV. So our intention is to use multiple FSK now, and rather than having 2 tones, we're looking at using 18 tones in this scheme called Domino X. And its PR is that if you can hear it, you can decode it. So there's a lot of error correction and error detection.
In terms of, if we're looking at not using the MIDI stuff, PSK mode, if we can do a phase shift, would probably give us better receivability than obviously.
Well, there seem to be mixed. You seem to get mixed messages on what's the best. I mean, David was saying that there's not much advantage to using Domino. He's still using the RTGY. So it's
50 baud is again, if you can hear it, you can decode it.
yeah. So
Well,
what we're thinking is
I've tried it and it drifts so much. That may actually be the SDR or the PC rather than the transmitter.
it's one of the things we want to try. So we will probably set it up so that we can send both and try it. So we do a launch and and have it sending RTGY and Domino EX alternately and see which is best.
I mean, the main thing we've got to do is be sending stuff that the network of trackers will track. But we should be able to send other stuff.
Does that mean we need to do the Domino EX in software with whatever microcontroller we're doing?
Yes.
And how complicated is it?
It's not that difficult. I mean, it's the because you're going so slowly anyway. No, it has been done. I mean, we have the board. I'll go through in a minute, but we have a DAC that's driving the output anyway. And we've got DMA and stuff, so we can actually send out. We can do a string and send it out because our transmitter is programmable as well. We can play around with the frequencies if necessary to get the offsets right. So we have a lot of programmability on the transmitter to be able to try different modulation speeds on the fly.
So what do you transmit over the RTTY? So UK has as a telemetry string that they describe. The tracking network which gives you this. So basically the trackers will track the balloon and they'll send the data off to a central database, and then you can monitor that data on the database, and you can see your balloon flight track, and you can see that it can do some interesting stuff. Anyway, coming back. So there's a standard string. So you basically you can have your own string, and then you define what that string is as part of your registration on HABHub, and then the trackers can use it. So HABHub can deal with virtually any string, but it makes sense to go with something that is fairly simple. So a call sign. So I reckon we should use RMS crypton or something. And then you have time and then data off of the GPS. So it's latitude, longitude, altitude. Optionally, you can give speed and bearing, and then you can give some other internal data such as temperature. Might be interesting.
Battery voltage.
Oh, battery voltage. In fact, if you look, that tends to be monitored as well.
So speed, altitude, or speed over the ground?
Whatever the GPS is giving me.
Yeah, it's going to be what you can give.
It's that.
Well, we can do both. It is purely optional. But the key thing you need is the latitude, longitude, and altitude. And then you give a checksum, and there are some options as to what checksum you could use. You could use XOR, but it tends to get avoided because you can get collisions with XOR. And so the recommendation is to use the CCITT system. Now, when we want to fly a mission, we then have to register a payload document that you can have, and that includes definitions of messages. Okay? And you have to have registered to then get tracked. And then during the track, you can see something like this. So there's key data. Sorry, it's not. So that's the. Oh no, that's speed change in altitude. That's the altitude, date time, coordinates like longitude, battery, some flags, pressure altitude, I guess is distinct from that altitude. The number of satellites that you can see, measure temperature. This says who received the data. Okay, and you can watch the track live or historically. And there'll be some interesting tracks. There was one mission called B-52, which kind of went south, and at North Africa turned left and headed straight for Israel, so it could be quite interesting. Right, so there's it's not just regulatory we have to pay attention to, but there's also working properly with the community, because this is all voluntary. Okay, so that's kind of an outline of what the mission would look like. So this is, I'm going to try and do a demo now to show you some components. Used to experiment with this. So this is a breadboard, and it's the one I showed you. So this is the GPS, that's the NTX transmitter. This is an Arduino Pro Mini. So an Arduino Pro Mini is a small board. It's basically the same as the unit, it's the blue board there. What it doesn't have is a USB interface, so you then need the USB TTL board. But combined, those are virtually a unit. There's a new Arduino out called a Micro, which is the same as the Leonardo, and you no longer need it carries USB, so you don't need this board to do the programming. Okay. It's on here both to allow you to program the Pro Mini, but also to give it power if you need to. The Mini's nice because it has a raw power input, so it will take unregulated voltage up to 12 volt, as well as a 3 volt power pin. But if you power it through the unregulated, it will then come out 3 volt up to about 100 milliamp, so it's good enough to drive a GPS.
If the primary battery in the payload is going to be a lithium cell, we're going to get 3 point something off that. Plug that straight into each of the.
I would try it.
If we blow it up, we'll
Yeah, but I mean, you just put it in the drawer to be on the safe side. So it's not but then you would power these two via the 3 volt regulation off of that board. But Richard's using a different processor to this, which accomplishes the same thing as the Pro Micro. And he's got a
What do you use?
power management.
An X Mega.
But this thing you've been talking about afterwards.
But on that's a 3.3 volt Pro Mini.
Yes.
But yeah, I mean because if you're running 3.3 volts, then you don't have to change the I/O voltages either, do you?
No. So there's no level changing.
So if you're running off a 5 volt, and even if you're powering it off a 3.3, then you should put the transmitter's okay. You can just put resistors in the transmitter leads. But for the GPS, I'd probably use a level sensor.
But then sensors, all the sensors are
You need to talk to GPS. You need to talk to GPS.
You need to receive bits of
Well, if you want to program it, so if you want to put it into well, yes you do, because if you want to put the flight mode, for example, for nav mode.
Do they store? Does the GPS have a supercapacitor battery or something?
You can put a battery on it.
Battery on the back. I haven't done it on this one.
But at which point we can program it all in the lab before we build
Right,
it.
so you're going back then to
Okay, fine.
what you saw there, because so this was just for me experimenting with some of these components and understanding the work chain. The tool chain and the design of the tracker electronics is something that so that's hacked together, and all I've done is I've taken the Arduino code off the UK has website to implement a beacon. So it's not reading a GPS, it's just putting out basically a string over RTTY at 50 board. Okay. Then this is an SDR, so this is a £10 dongle. So it's a DVB-T dongle that can receive up to 1700 megahertz, so it's quite broadband.
If you believe.
Well, if you believe it, yes. So to use that, there's then an application on the PC called SDR Sharp, which that combined with that gives you an SDR receiver. And what you then do is you run another piece of software that is an audio driver, and it allows you to take audio out of one application and pipe it through to another application, which in this case is this app here called DLFLDigi. What it does is it takes the RTTY and decodes it, so eventually what you then see are the beacon messages.
Is this Windows only?
No, well, that is Windows, I think, but that one is, it uses C#.
Right.
So you could potentially run on Linux with Mono.
But there also lots of other software you can use.
Is it?
But that,
Yeah,
There is GNU Radio, isn't there?
well, GNU Radio is a very, very complicated way of writing the software yourself. But it's QD just what one.
Does it?
Nice
switch this off.
It's worth, when you're starting, you want one that you know works. You don't want to start with GNU Radio. So.
Yeah, I've never got the new radio to work.
Well, it's good.
Oh yeah.
Okay, so what I'll try and do is I'll try and get it set up and working. Now the problem I had was the initial example on the UK Has site, you basically set up a voltage divider as the basis to waggle the voltage on the transmit pin. And I tried it out and it worked fine, but then they changed it over to a PWM setup, and it's not as consistent as the voltage divider. Unfortunately, I saved voltage divider example, and it's disappeared off their site and all the other sites. They may be embarrassed by it. So what I'll do now is I'll show you the setup of these various things. So this is SDR Sharp. Okay, so I got the dongle plugged in over here. The dongle you saw a picture of. That's a USB dongle. It's plugged in there, and it's got a whip antenna, which refuses to stay upright. Okay. So what you do is up here, you specify the source of the signal that SDR Sharp's going to see, and in this case it's the RTL SDR USB dongle. You set the application to monitor on the on USB sideband, and you tell it to play, and you hear a noise. Okay. Right, so what I use to test whether I've got the thing set up properly is this thing, which is a key finder, which screams on 434 megahertz. So when I press that, you can see the spike. So it shows you what a strong signal would look like. So I'm now, if I plug, so I'm going to plug this in, which is running a bit of code, and all it's doing is broadcasting that beacon string. But at this point I've not put the decoder application in, so you're just going to see the signal up here. Okay, so you've now got peak. So what we can do is we can scroll over to there. And you can hear the telemetry. So this is doing basically what you were saying, do with a podcast. It gets very annoying. Now what we can do is we can zoom in. Okay, so that's the telemetry that you see, and then what we have to, I'll now kill the sound on that. So then the other application is DLFLDigi, that's the one I mentioned. Bear with me a second. Right, where's my thing? Oh, there. Okay, so it's seeing the two peaks, so these peaks. You're seeing it over here, so now I have to get this set up so it will pick that up and then start decoding it.
What's the
So how's-
deviation then on?
Don't know yet.
Oh, right.
So how is that deriving its signal? Is it an output from
This
the
one.
software,
So
from the SDR?
this is, you heard the audio
Yes.
signal.
Yeah.
So that's the signal carrying the RTTY.
Yeah.
So that's gone through this thing called VB cable, which is a driver that takes the audio output from one application and allows you to
Okay.
make it the input to another. So it's the input to this one at the bottom.
Okay.
Okay, so that's what
Yeah.
voltage is. So I have to get this one set up right.
Yeah, the deviation's about 300 hertz, isn't it? I can't.
300 either side. No, 300.
Well, it's going from
there.
2500 up to
425.
2800, isn't it? So it's about 300.
So it's 425 as a carry shift.
But yeah, but what we're seeing there is a bit less than that, isn't it?
Over there. What is it? No. Oh yeah, it's probably about 300.
Yeah.
Which may be why it was problematic. Let's see.
It's 300, not an option.
Let's try carry shifting at 350.
Faster than that. The custom one.
What's the stability of the NTX2 then in terms of
I find this one was running a lot.
frequency?
Surprisingly good. I put it on the frequency counter and
Over temperature range, yes.
yeah, I mean it's well I haven't done it over wide temperature range. I mean, it does vary, and I mean the stations receiving stations are used to that.
Right, right.
so
because you've got to sort of like track it if it
Yeah, so they do.
if the centre frequency.
Yeah,
drifts,
they do
which they can do.
fiddle around with it.
So
Yeah.
having got the parameters right, you can see that it's picked up the beacon and it's now printing out. So the RMS Krypton TTY test beacon, with a carriage return at the end to make it nice and friendly.
And so what bit rate are you using there?
That's 54.
Yeah.
Let's look. Uh, 50 baud, 7 bits per character, no parity, 2 stop bits. And that's 280. is the
So that's
character
actually
shift.
9 bits per character
Yeah.
and 50 bits per second.
Well, there's a start bit as well.
So implicit.
Okay, so that kind of setup now gives you the basis for getting one end, talking to another. This is quite stable, and I tried it at home, and maybe there was a bit of noise around on that band, but I found it drifted off. You have to get that deviation quite accurate.
I found sometimes the SDR buttons are quite temperature sensitive.
No.
If you hold it, it will just
Yeah,
go.
well,
Sorry?
quite
The
bored.
top one output in audio.
Now, I've got some questions. Okay, because I know enough about radio. What is that?
No,
There are
it's
4 peaks there.
basically shifting that frequency.
Those audio.
The one dead on your red line is a DC offset in the dongle itself,
Yeah.
and you always get that when it's not really there.
So that's what this
Right.
one it's taking.
So it's these two.
Yeah.
peaks.
It's the spectrum.
Right. So these are the side back.
It's
So what's that? A DC? So the middle one is what? DC?
I don't know.
offset?
Well, I don't know. That's. I was explaining the one I could explain, and then I'll leave the rest of the other.
Because
feedback. No,
they
no,
look
no.
like the side bands, but
Yeah.
what?
So if I can, let me zoom back out.
It's doing it so that
Can you actually stop the stop modulation it?
You want me to pause it?
No,
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 just remove the modulation. just see what?
Just get the carrier.
Just get the carrier.
Unplug your
I'd
data
have to
line.
change the code.
Just unplug your data line.
Oh, okay.
Yeah.
So they're still there, but lower.
Sounds like
Let
it'd be
me,
an
let me
artifact
plug
again.
it back in again.
And how far down are they? They're from. What's the peak? What's the?
Well, peak looks to be minus 25 about on there, and they're at
Yeah, minus 25.
40.
That's where
Minus 45.
well, it's probably
So
not.
if I then
actually,
take it off, they drop, well, they're gone completely.
it's saying
Well, not quite completely. You can see in the waterfall that it's still kind of there.
Oh, right, yeah, that's true.
Could you slow the heat map right the way down so you can see the highs and lows a bit clearer?
Right. Yeah, how would that roll? I can change the speed, but that's basically it.
On the,
Yeah.
I thought it was visual speed on this heat.
Well, speed it up, I think is what he was suggesting.
Be interesting to look on a real spectrum analyzer, wouldn't it? Just.
Anyway, so that's equivalent to basically the various components that will be working in a balloon. Won't be using an Arduino because this one's what, a 328 running at 8 megahertz. We'll be using X Mega. Which one?
3284 U,
Okay.
so that's 32 meg.
So it's more I/O, more memory, more clock.
Because those peaks aren't modulation, are they? I'm wondering if they're an artifact that's actually introduced by the dongle itself.
Yeah.
I mean, I think that because the actual 500 hertz or 300 hertz shift, we wouldn't see at that scale. So, would we? Because you're
Yeah, you see these two peaks, which are peaks.
no, they're not. The one on the right is the actual peak, is the actual signal.
Oh, is it?
So the one on the left is the DC through the one on the right. Just whether that slightly shifting about is actually the modulation. I doubt even that. I don't think you can. The scale you've got there is not.
Yeah.
It's quite coarse, isn't it?
How far away are they from that
Yes.
centre?
Can we zoom in a lot?
Yes. How far away are they? That's a good question.
Oh, that's interesting.
So the peak on the left won't move unless you retune the
Yeah.
unless you change your centre frequency.
How close do you want to get? That is 0.0318. That is 0.038.
Yeah,
Well, actually it says, doesn't it? 0.41, 0.041, 0.301.
So that's frequency you've got your receiver tuned to, so
Yeah.
you'll always get that offset at that frequency. If you
Right.
change that, that'll move.
Alright, okay.
So the ones that are interesting are this to the
Yeah.
whatever's over here. So
So that's-
yeah, so that gap
Mhm.
there.
So what are these?
That's what we're trying to. That's what we're.
Can you give us the distance between the two side lobes and we'll halve it?
Which one? Sorry, which
That
one?
one, yeah.
This one?
No, not the big one.
That one?
Yeah, that one. And then the small.
And that one?
No, those two.
Oh, those two?
Yeah.
Right. So that is 026
026.
and that is 058. So half of it is 026. No, it isn't. 026, 058. 32, 16 is half. So 016.
16
But isn't this program doing tuning off anyway because the centre's no good?
No, that's what that.
The peak under the red line, that's what that is.
Yeah.
Does that move as you choose?
Yeah, it's usually that one, because that's dead on this frequency.
I thought you'd done it the other way. No, so that is.
Yeah.
Oh well.
What PWM frequency are you using?
Oh, that's interesting.
That's the dongles being.
The dongles are rubbish.
Cheap.
Cheap chips. They are, I mean, for what they are, they're really good.
Yeah, well.
They're amazing for the money.
Yeah, exactly.
Wow.
It's like the fact you can do that
Absolutely amazing.
And the range as well goes down to like 100 meg or so, all the way up to 1.7 gig. I mean, there's a gap in the middle where it can't do it, and you're not entirely sure exactly what you're really getting because they're only optimised for bad frequencies.
Oh, right, right.
Yeah,
But it's all over when the modulation was off.
They're better.
yes, but very, very, very much
That's
lower.
lower.
So it could have just been noise on the input pin, or you don't do.
No, no.
Not 10 times better for 10 times the price.
I don't like the PWM on the modulation input.
Are they only doing it because there's...
It's going to
Yeah.
be enough to give you the
Yeah.
6 kilohertz.
But is it externally smooth?
So let's
You know,
say
when you set up the PWM, it should have set the frequency.
Right.
the HF is no use to us.
Oh yeah, there.
Yeah.
Is the PWM signal externally smooth? Filtered?
No.
What, you just put the PWM straight in? Is that?
I think if it's going faster because of the bandwidth of the actual device, I think because if
What's
it,
the PWM frequency? It's
well,
quite high.
yeah, well that's what we're just checking.
Yeah.
So where do you call set PWM?
Radio pin, while we're on radio pin, is on 6.
And that's
Nine.
the device. One is the
So you're
divisor.
saying it's a 1, is that?
So you go back down to set PWM.
9.
That's the divisor.
So the divisor is 1. So
It's mode 1, so go down.
This one. Mode 1. Case 1, mode 1.
So that's for saying different pin.
So yeah, it's at full speed then, isn't it?
but what is full speed?
Have you got pull up the NTX2 datasheet just because I think it's got an internal block diagram, hasn't it?
16
Yeah, I mean they're
I think there's some filtering inside.
I think it is filtered, but just how much? I mean, it may be an artifact of the
But it'll
PWM.
be counting up to 256 if you haven't set anything. Or no, because
No, it was what's set to 1, wasn't it?
well, no, that was setting
We'll
the
put a scope on it
volume,
later and
not
have a look.
setting the top.
The easiest way. The real scope.
Okay.
I have been
Next bit.
trying to convince myself that I want.
Will you use this sort of receiver for the real thing, or a more
Probably no,
a
no,
more
they're not.
communications type receiver?
Yeah, I mean,
they're
they-
using comms receivers,
Oh,
but
yeah.
when we'll give it a go, and certainly when we want to test
Oh yes, yeah.
the rig on a tethered balloon, we'll
Yeah.
use an SDR. It'll be interesting to see how far we can go with one
Yeah.
of these.
If you look at the receivers that they're using, when you saw the map of the tracking stations, I mean, a fair number are using sort of Yaesus and
Yes.
that sort of
As good
thing.
as you can get.
There's a better dongle called the FunQ,
Oh yes, I've seen.
which
that
I think
on
has
film.
some front end filtering in there, and then there are people who are using proper SDR radios as well. No, these dongles are typically not used for the real thing.
No.
I have got, and I haven't tried from Hab as well. They do a preamp with a 434 filter in it.
Bandpass filter in it.
Yes,
or some sort.
so that's another thing.
Oh,
is
that would be
we
well
want,
worth doing, wouldn't it?
thereabouts.
Because I mean, this is a wideband receiver, isn't it?
Yes, yes. So they're doing about £30 or something like that. It's just a sort of
Yeah, just a bandpass
proper,
filter.
a nice sharp filter and a hemp or something preamp.
Okay, so you're up next.
Right. Yeah, so this is just some of the, go through what we've done with the hardware, linking all these bits together. Because we didn't have the model until recently, I've made up just a development board so we can actually try the bits. First thing is power supply. I did the power supply on a separate board. So basically, as I said, we're using lithium primary cells. Energizer Ultimate seems to be the favourite, and they're used on most of the...
3 voltage?
The 1.5.
Okay.
And then also you'll see on the back of the board what I've done is just put a boost regulator on the back. So basically it's a 3.3 volt. You can change the components if you want to make it a 5 volt. Or you can have 2 batteries on it as well. So you can actually feed 3 volts in and get 3.3 out as well. So that basically the AA cell I've got here is about 200 milliamp hours, 2000 milliamp hours. Might not be able to fit that into the actual model.
We're going to cut Superman up and put
Yeah, we're going to.
components inside.
So we're hoping the batteries would fit in the legs. You may have to go down to a AAA cell. AAA's are I think 1250 milliamp hours, so we may need 2, although
1 in each leg.
yeah, one in each leg.
Philly's boots.
Well, this will come down. In one of them, this will come down completely separate. So
That's the actual reason.
yeah, so they want to actually see this as a completely separate item. So we do want to track that. So that was the. It's a bit choose, I guess. Be the biggest we can, I guess. That was the. They wanted to see something built, and the. So this is the regulator, just a microchip boost regulator, switching regulator. The board was made by our dirty PCBs friends in China.
That's a useful little board, that is, isn't it?
It's just a one of the other things is I may rework it. It turns out that it's about the same size as the prototype breadboard, so if we just put some pins on the bottom, we could actually just have it as a...
So this is a commercial breadboard power unit, and it will give you 5 volt or 3 volt 3. So one thought is to have this, but extend it by and have a battery on
the back.
Yeah.
And is that wide enough to go to do both rails on a typical breadboard size?
Yeah, well, yeah, I mean, we can fiddle around with it, but that is about the breadboard size.
Oh, that's a really nice little board.
It's supposed to plug in.
Yeah.
Okay, so you get...
This is a spark phone unit. What you can't do is have different voltages either side, which would be nice. But there is another one, which is a lot bigger, that does give you differential voltages.
If you want 6 inches for an antenna, you can stick one of those in.
No, they're not here now.
Put it under the cape.
Yeah.
So which?
I was going to turn his cape into a parachute. Folded
I was thinking on Wednesday.
Put his arm out
on
on
that
that
one.
dipole with one other board.
Well, he could be sort of carrying some sort of lance, couldn't he, or something?
Yeah, so they developed this board. I mean, component cost is about £1 or something.
Problem solved.
It's very I use the microchip. A lot of the TI do a nice boost regulator, but it's quite a lot more expensive, whereas the microchip ones are only 30p or something like that.
How much current could you get out of the higher current?
If you want more current, you probably need 2 batteries. Is the only thing, because I think the losses start to mount up here. I think that you could probably get to the 200 or 300 milliamps out of it, something like that. The TI ones are much better at the higher current,
£1.20.
Oh, I've got them. I've got a couple of them. Yeah, they're excellent though. Breadboard power supplies. Cool.
There's a standard robotics kit that they do for schools in China, and this is the power supply for it.
Yeah, so the thought was maybe to put some pins on and make it a more general purpose device. this is just the input output, and I mean, I put here, either I just put a link on here for the to switch it on and off, or you can put a switch, or if you have two batteries in series, then you can just put the other battery into that one. So the board itself, which is this one, as David said, the radiometrics, so these are the frequency agile ones, so although they come set to a frequency, you can change that to any frequency. The blocks GPS, as we've already said. Pretty much SD card slot, and an FET output for the cut down for actually releasing the device. So if you want to actually drop it from the balloon, so typically they use just a resistor burning through a nylon thread or something like that. Put about 5 watts into the resistor and take out the thread. There's an external connector I put on here because we may just use the same board when we're using with the Raspberry Pi. The capsule and maybe the wing may have Raspberry Pis, quite like to have Raspberry Pis as their controllers. So if we can use this board with the Raspberry Pi, that's an advantage. I did put a thermometer on the board again just to play around with it. Probably unnecessary. There is actually a thermometer on the processor itself, and also I put the thermometer on the board, but I mean it should really be external if you're really trying to measure the temperature, because what you're going to measure on the board is not representative of the external temperature. I also put a pressure sensor on there for altitude, but again the typical sensors that you get and the one that I used is only good for a few thousand feet. I mean typically the pressure range that they operate over is quite limited. The one I've got on there I think only goes down to about 0.5 bar or something like that, which is only a few thousand feet. It's no good for the very, very low pressures that you're going to encounter. And but for altitude we've got the GPS anyway, so it's a bit of a nice to have. It's just
Well, it's a good backup of the GPS towers, isn't it?
yeah, but only very low altitudes. You know, it's only good for a few thousand feet.
Those are the ones we worry about, aren't they?
Okay, so, yeah, as I said, it uses the Xmega A128A4U, so it's 128K of flash. Yeah, so the reason, I mean, it is, well, most people are using just ordinary 80 mega 328, the Arduino type processor. Decided to use the Xmega, hadn't used it before, thought it was worth a try. This particular one, the A4 range come in 44 pin packages, so fairly small. It's a bit faster than the 328. It runs at 32 meg when it's powered at 3.3 volts. 128K of flash, 8K of RAM. There's a USB built into the chip, so for actually just programming and setting it up, there's a DFU bootloader built into the chip.
To use Atmel Flip to program it.
Or I forget what you use under Linux. There's another one under Linux.
It's basically a bootloading attempt.
One of the advantages over the 328 is there's lots of peripherals. There's 5 UARTs, 2 I2C, 2 wire interfaces, a couple of SPIs, there's 5 or 6 timers in there. It also has quite a clever event system, so you can take events like timers and pipe them as events to trigger other things. So you can use a timer to automatically trigger an A to D conversion or something like that. So there's like an internal hardware event system where you can map events generated internally to the chip directly to to some of the peripherals. It has plenty of A to D converters. I only use them for measuring the battery voltages. It has a D to A converter, which is so we don't have to use PWM. We can just take the output from the D to A converter directly into the modulation into the transmitter. The output of the D to A is 0 to 1 volts, so I have to play around a little bit with the trim frequencies to get the right and the right frequencies coming out of it.
So this is if we want to do the Domino X.
Well, even with the RTTY, I play around with the frequencies to actually keep it in band, because normally if you've got a 434075, then it will send out 434075 if the input is at 1.5 volts, effectively half. It's a 3 volt range, I think, on the modulation. So it's effectively then plus or minus, and so the frequency then shifts. But I forget the total shift is it? It's about 6K.
6, yeah.
So it's like plus or minus 3 then. So 0 is 3 kilohertz below that, and 3 volts is 3 kilohertz above that. Was it plus or minus 6?
No, I'm sure plus or
three.
minus 3.
Yeah. I put a crystal on the board, but in fact it's got an internal trimmed 32 meg oscillator, and that's I found to be very good. We're not particularly demanding on timing anyway, and when it's using, the only thing that could be time critical is the USB, but then you can set the processor up to automatically adjust itself based on the start of frame messages coming out from the USB anyway. So
so if we're going to provide a transmission service for the Pis, how are they going to communicate?
yeah, through the
UART?
yeah, on here, this has got a UART and also another I2C, so we can either do 2-wire or the UART.
Or the USB?
Yeah, you could do the USB.
The thing is, with USB you're going to be using a lot more processing, so you're going to be loading on the battery, aren't you, more, if you do that? Because ideally you want to be...
Yeah, I mean, one of the advantages of these X-Megas is that they are very good at power management. You can turn almost every peripheral on and off as required and put it into sleep mode and all that sort of thing. So all the peripherals that you don't need, like the USB, you can just turn the clock off to it, so it's completely powered down. Power is not going to be a big issue for us. We've got 2,000 milliamp hours on the battery. Even fully powered, we're under 100 milliamps.
I mean, it's more the USB on the Pi.
Yeah, that's the point.
Well, the Pi stuff will have bigger batteries anyway.
But you're going to be reliant on this to find your cameras and your Pis. So you don't want to, even though you've got 2,000 milliamp, you don't want to unnecessarily waste it, because it may run out just before you need it.
Yeah, so we can do either with that. Yeah, so the power management is really really good on these things.
You've gone back.
Sorry, that's running forward, isn't it? Yeah, so that's right. Yeah, this is one not completely populated, but basically just the 3.3 regulator is when you power off the USB. Otherwise, the power's coming straight in. I haven't populated the monitor and pressure sensor on this board, and then just the SD card's a bit of a nice to have. I mean, we're going to have to relay this out to fit into the model itself. Have a smaller unit. When I laid out the board, I did it so there's nothing under the these two, the GPS and the transmitter. It's going to be a bit more of a challenge when we do a smaller board.
Did you mention they're supposed to be open sourced?
Yeah, I mean, well, everything there. I mean, everything is open source. This board was made by Seed. The other one was made by Dirty PCBs. Slightly, the Seed board is a slightly better quality, I think, better than the Dirty PCBs, but a bit more expensive.
Have RS asked about using? Do you use Design Spark or? Because there's a bit of an issue here. They prefer the use Design Spark.
Yeah, these I did with Eagle because I always use Eagle, and they are going to move them over to.
Oh, they're going to do this. Yeah.
Well, I mean, I can, but
yeah.
I could, but there's meant to be a tutorial up on Design Spark of how to transfer Eagle stuff over. It's not been written yet, so my excuse to them was I waited for that to be written to know how to do it. You can. I have exported it from Eagle to Design Spark, but it's not quite right. It's not, and it needs it. I mean, I think it needs work.
Reworking again, doesn't it? Yeah. And it's sometimes more trouble than it's worth to rework it than to start again.
Yeah, yeah. So I didn't really want to spend my time with me to Design Spark. Yeah, I mean the software I'm working on now, the tool chain. I'm using Atmel Studio. Obviously there's a Linux tool chain as well. I'm using the Atmel software framework libraries. They're nowhere near as mature as the Arduino stuff. I mean, obviously that's obviously a consideration, but they generally work. The documentation is atrocious and non-existent.
Setting your standards fairly low. That is setting your standards fairly low.
Yeah, I've been doing the 2-wire interface for the GPS, and there are some issues of how they describe stuff, and I'm having a few problems with that. They say nowhere near as mature as Arduino, but it's a nice process, and I think they're about £3, £2 or £3, something like that. So they're quite reasonable price.
There's other ones. I'm using I'm looking at the 8 E5, and that's cheaper than any of the Megas at the moment.
Yeah.
Really cheap. It's 70p or something. You can order 10.
Yeah. And available.
Is that your last one?
Oh, this is just plenty of peripherals on there. So the transmitter I'm running off. So the UART goes to the enable pin because I can use that to send a serial string to change the frequency and to trim the frequency. And then the D2A converter drives the modulation input. Micro SD cards on the one of the SPIs. The USB, so it's internal, and the 3.3 volt regulator. So you can either run off battery or the USB.
So does it need external on the USB?
Sorry,
is it an external mux on the USB, or why is there a separate box for the USB?
It's just the connector. Really. I mean, even the series resistors are in the chip, so you don't even need series resistors. Some of the other processors, would have USB. Some of them require an external transistor to put the 1.5K resistor in, but this is all in it, and even the series resistors are there. The cut down FET is on the GPIO. They provided a separate I2C for the Raspberry Pi interface and a separate UART there for the Raspberry Pi. So it could be a slave, it could be an I2C slave for the Raspberry Pi. Obviously the other two are interface, which is the master, is driving the temperature sensor, the pressure sensor, and the GPS. The GPS has both serial and I2C. Count. So there was one spare, and there is a software package, U-controllers that the U-blocks make, so you can just use the board and use this as a serial to USB converter and just talk to the GPS.
I have it on here, I can't remember. I've tried it with that. I think I may have done it on my desktop rather than this one, but I'll have a look during lunch.
And so that's all that there is into it. So the boards have been designed and got made. The components are all from RS, and RS have provided those components except the two major ones. Right, well, that's me.
So the other one then is the casing.
And the USB.
Oh, and the USB. I'm not sure. I did get some of it. I'm not sure if this is one of yours.
The pizza's here, obviously.
Yes. I'm done.
Right, I was just going to see if I
Pizza
can
ready.
find the case.
I love it.
Is it your laptop running it?
Yes.
What's it doing?
Recording video.
What, live?
No,
From the RS?
first. I thought I might as well try and
Oh, right.
render it down.
So
it
doing
takes time.
we're doing some cases for the board as well, so that'll be open sourced, but not through
Using the new
through
RS.
thingy version.
But
No,
we
no,
might
no.
not use a case if we're putting it in Superman, or would
Not
we?
if it's in Superman, no. But I mean, there's the general design, and then there's the custom. So this will be a design case. So basically, it just keeps the thing safe rather than carrying it around in a plastic bag. But then then it'll have a flight shell, which is this low density fill for when it's put in. If it goes into a balloon. So I haven't got the edges yet because we're trying to decide what I/O we actually need during flight, but that's all. So there'll be a 1 centimetre honeycomb shell around it, so if it does hit something, hopefully this will survive. What it hits might not. And that's been done in SketchUp. It'll be a SketchUp file rather than what?
You need to use Design Smart Mechanical.
Well,
Why not?
it slipped my mind. Right, okay, that's
So
it.
Alex is using the.
OpenScan.
Well, he's using their printer, isn't he? What's
The
Oh yeah,
Ormerod, is it?
Ormerod, yeah.
Yeah. So
the one that he's embiggened.
yeah. Well, so RS provided that for him to.
Oh, I see. I didn't realise that.
Yeah, I mean, RS are offering to. I mean, they've provided the components, and they will put some money into the Hackspace as part of the deal, either as component supplies or whatever. So we will get something out of it as a Hackspace.
Oh, right. Yeah.
Very suits.
And they've been very generous already. I mean, they've given us 10 Raspberry Pis and cameras, and we often get bags of components and stuff like that from them. So it's a good relationship.
Yeah.
Just a nice snack in the afternoon.
We wouldn't do anything exclusive with them. So I mean, we're talking with Farnell as well, and 14 and that sort of thing. Because we don't. Sorry?
Ryan wasn't very impressive by now.
Why?
They came to him and he said, so what kind of budget have you got to do this stuff? They went, oh, at least 50 quid.
What was it for now? What did you do again?
They just wanted us to do like podcasts and stuff.
I have to say, as a sort of user, I find Farnell much easier to deal with than RS.
You can search for things on their website.
Yeah.
It works, kind of doing that. Personalisation works.
Yeah.
And we got those up eBay.
Oh right, yeah.
So it's a mini PCA card, really.
Oh, okay, yeah.
It's got uBlock 5 on it.
We're better shown about
And that's got a built-in flash for, so you've got smooth external memory. That one does it. And it's got flash entry stuff on it as well. But yeah, we never actually ended up using it.
This is vegetarian, that's just pepperoni. Otherwise, meat and chili and pineapple.